equals 4. So if you have the velocity, what do you have to find? Derivative of velocity, correct. So that's going to be cosine pi over 3t times what?
Pi over 3.
Times pi over 3, exactly. And for some reason this is just freaking out. Times pi over 3, absolutely. And what are you evaluating it at? V prime of 4 is going to be cosine of 4 pi over 3 times pi over 3. What is cosine of 4 pi over 3? Negative 1/2, right? So it's a negative 1/2 times pi over 3. So you end up with?
Negative pi over 6.
Yeah, how many points do you think this is worth?
1, 2.
2 at the most, right? 2 at the most. Okay, so let's move on. So then the next question is asking us, consider the following 2 statements. Okay, we're considering them. I'll pause this while I do this. What does it mean for the velocity to be decreasing?
That larger value to a smaller.
V decreasing means what?
It's getting
Going from larger to smaller, which means what is true? The acceleration is negative means that V prime, it has to be what? Less than 0. So let's just actually figure that out, right? And this is a calculator section. Seems like it's going to be necessary at this point, I think. So we did the derivative already, right? What was the derivative? Yeah, V prime of t was pi over 3 times what?
cosine pi over 3.
Cosine of what? Pi over 3t, correct? So what are we really interested in finding first? If we're interested in finding out where it's less than 0, what do we look at first?
Where it's greater than 0.
Nope. Where what? Where it equals 0, right? So you want to solve pi over 3 cosine pi over 3t is equal to 0. So that's going to be when cosine pi over 3t is equal to 0, right?
Yeah.
What's cosine inverse of 0? What's the smallest radian value? Pi over 2, right? Pi over 2 plus pi n, right? Plus pi n, right? Does that make sense, everybody? You can go pi because it's going to be 3 pi over 2, then pi over 2, then 3 pi over 2, right? But you know that that's going to be equal. So you know that pi over 3t has to equal what? Pi over 2 plus pi n, right? So what are we solving for? T. So t is going to be equal to 3 over pi times what? Pi over 2 plus pi n. If we multiply this through, what do we end up with? T is equal to 3 over 2 plus what?
Plus 3n.
Plus 3n, right?
Yeah.
Okay, that actually works out really nicely because what range for t are we looking? We're looking at t between what? 4.5 and 3, right? So, well, almost. So the n values are integers, right? So we're talking about if n is 0, you have 1.5, right? Is that in between here?
Yeah.
1.5 is between those, right? And then let's say n is 1. It's going to be 4.5. Is 4.5 in there? No. Let's say n is 0. Oh, sorry, n is negative, right? It's going to be negative. So is this going to be equal to 0 anywhere in this range? What did we just showed? V prime of t does not equal 0 when what? When t is between 3 and 4.5, right? We just showed that. Do you agree with that?
Yes.
So it's either going to be just positive or
Just negative.
just negative. So what do we have here? We have v prime of t is equal to, what was it? Pi over 3 times what? Cosine of pi over 3. So what value should we test?
4.
Wait, did we just find that already?
Yeah.
We did. V prime of 4 is what? What was v prime of 4? Didn't we just find that out?
Negative pi over 6.
Negative pi over 6, right. Which is less than 0, right? So what does this mean? It's going to be decreasing. So this is therefore true. Do we agree with that?
Yeah.
It was important though. Why was this math important right here? Why did we have to do that? To show that there's no 0, to show that it's either always positive or always negative. If we found a 0, we need to test both sides of it, right? But we just showed that it's never 0. The derivative is never 0 in between. The derivative of v is never 0, right? So we just showed that the acceleration is always going to be negative because the one value did we already test it? Yeah. And when you get nice symmetry, not symmetry, but like symbiosis between the parts, is that usually a good sign? Like we needed to look at that. What did we need? Hey, we need, oh, this is your first good sign. Did it cancel nicely? 3 houses, 3n. Oh, that's great. And then, oh, look, a number between 3 and 4.5. Did we already test one? Yeah. So are they setting you up for success here?
Yeah.
Yes, they are. This is very, very much on purpose. There's always just positive or just negative from what to what?
From 3 to 4.5.
Yes. Negative 4, 0, t, and 4.5. So what do you need to test?
3.
Yeah, well, no, we need to test something in between, right? So again, what? But it's the velocity at 4, right? Because we're not, this is velocity, right? So v of 4, so that's going to be, I'm sorry, what's the question, Sam? Okay, so what's v of 4 going to be? That's going to be sine of 4 pi over 3. Did we already do that? Did you have to do sine of 4 pi? Oh, you did do cosine, okay. So what is sine of 4 pi over 3? So that's pi over 3 plus another fourth. So is it going to be? Is it root 2 over 2? You sure? It does seem like we are. Did we get it right?
Yeah.
Yeah, 1 is correct and 2 is correct. Good. But that's the key thing. Speed is increasing if they're in the same sign. If both velocity and acceleration have the same sign. Yes, absolutely. But I'm going to need to integrate, right? Math, right? Math 9, thank you. And then what am I going to put for the function? Nope. How do I get to absolute value? Math. It's num, right? Yeah, there's an absolute value of what? So vars, y vars, function y1, right? Well, I got to close it, right? Comma what? X, comma, 0, comma, 4. Takes a little while when you're using the absolute value function. It ups the computing, and also these calculators are notoriously not so powerful. Yeah, lights on fire. Yeah. That's just not good. Literally, if you wrote this, you're done. That's it. What's the total distance traveled? And then you need your units. Did it give us units on this?
No.
I don't even think it did. So what would you have to write for your answer? Can someone tell me what the...
Units.
Yeah, no, well, 2.387. You need exactly 3 decimal places. You need exactly 3 decimal places. Let's see how we did. If we don't have that, can we answer this question?
I have a question.
Let me finish this one. Okay, so how do you do this? Do you add distance traveled to 2? No. Distance traveled is, I go out 10, I go back 10, I've gone 20, right? It's the displacement, and displacement is just the regular what? Yes, the position at time equals 4 is going to be the position at time equals 0 plus the integral from 0 to 4 of what? Just the velocity. Because just the velocity, this is the what? That's the displacement. Because if I started at 2 and I went 10 that way and 10 back, what's my position?
0.
If I started at 2 and I went 10 that way and 10 backwards, where am I? 2, right? You need displacement here. This is not distance traveled, right? So literally, can you just do this on your calculator?
Yeah.
Yes, absolutely. You do the exact same thing. Is this going to be the answer I want? Plus 2. Done. Some people forget. I mean, do you need that? What's the only part of this question where you need the initial position?
This one.
This one. So sometimes you might forget that. But when you're asked for a specific position, it's going to be a numeric value, right?
Yeah.
If you don't have that initial position, can you finish this?
No.
No, you cannot. There it is. Let's see how we did. So let's simplify a little bit. What do we end up with? 5/3 pi r squared. What do we need to know to get the final answer to this? What is r? We need what is r when h is equal to 5. How do we figure that out? We know... What are some things we know? What'd you say? Aw, man, you're getting a gold star for that. Everybody, Matt Chang is getting a gold star. I'm going to pause. Matt? Similar triangles. That's basic geometry. Jackie, sit up, please. Okay, there's part A. Find the volume. Indicate units of measure. What's the unit of measure on this?
Centimeters cubed.
This is centimeters cubed, right? It's a volume, and it's in centimeters. Okay, great. Yay! Awesome. dv dt is equal to, I'm going to put this 1/3 pi right out here. We need to differentiate r squared h. What do we have to use?
One variable.
Product rule, or what?
One variable.
Or one variable. Do we have a relationship that we can go down to one variable with?
Yeah.
We want to remember, we want to relate volume and what?
Volume and, well, time with radius or height.
With radius or height, does it matter at this point which one we go to?
No.
No. What was h equal to? Well, this is h is 5, right? When h is 5? So can you just plug in 5 right now?
Yeah.
Can you?
No, you have to differentiate first.
Ah, okay. We have to keep it for a second, right? So let's just differentiate it and see how, let's go the longish way and then see if there's a faster way. We have to use the product rule. Do you agree with that?
Yeah.
So it's going to be 2r dr dt h plus r squared dh dt. Right. So we want dv dt when what's true? When h is equal to 5. So we have pi over 3 times 2r dr dt, what's h? 5 plus r squared, what's dh dt?
-3/10.
Ah, do we actually have that measure already? That's what we did in the first. What does it tell us here? It says it's always changing at -3/10, right?
Mhm.
That stays the same for the entire thing. What are we solving for in this? Which one are we solving for?
dv/dt.
We're trying to get dv dt. That's what we want, but what's our problem right now?
Not dr.
We have three.
We have two
variables.
things. Well, we have r and dr dt. So we really have two different ones. We need r and we need dr dt. Should we clean this up first? I'm a fan of cleaning things up before we move on. So what do we end up with? Pi over 3 times what? 10r dr dt minus 3/10 r squared. What's the first thing we can easily find? R. Exactly. 5. What's r? Did we already do that in the prior question? Yeah. Is this a sign that we're doing the right thing?
Yeah.
Yeah. So we end up with pi over 3 times 10 times 5/2 dr dt minus 3/10 r squared. So we end up with pi over 3.
R yet?
Not yet.
Okay.
Oh, I'm sorry. The r is right over here. You're absolutely right. I'm sorry. I didn't see that. 5/2 squared. So we end up with 25 dr dt minus what? Is that 75 over what? 40? Is that correct? Is that correct, everybody?
Yeah.
We good? Okay, so what's the last thing we need?
dr.
What's our confidence level with this? What do we think?
Kinda low because I get a different answer.
Okay, that's a relatively clean answer. Is that relatively clean?
Well, mine's cleaner.
Yours is cleaner. 17.
It was -5/2 pi.
Okay, I don't know. I could be wrong. We could be wrong. Let's just take a look here. Oh, look. What did we get? Did we get the same thing?
Yeah.
We did get the same thing. The work on these tends to be summarized. Do I expect your work to look like this? No,
Not.
not really. They're combining like 10 steps and they're simplifying, blah, blah, blah. But that's what they're looking for. Did we get full credit? Did we get all 5?
Uh-huh.
We certainly did.
So
Good
you
job.
could either solve for
We just showed this at one specific time. Is that enough? No, it's saying show for all of the values. So h is equal to 2r. So we end up with v, the volume, and so it's not v of t. It's going to be volume. Now we're going to have, this was in terms of r and h, right? Now it's just going to be in terms of r is equal to 1/3 pi r squared times what?
2r.
So we know the volume in terms of r is
2/3 pi.
2/3 pi
R cubed.
r cubed. Are you okay with that? That's the volume, right? What's the surface area at that given radius?
Pi r squared.
Pi r squared. Do you agree with that?
Yeah.
So let's do the derivative with respect to time of each of these. Is that okay? So we know that dv dt is going to be what?
It's gonna be
2 pi
r squared.
dr dt. Do you agree with that? And what's this going to be? dsa dt is going to be what?
2 pi r.
Sorry, that's a pi. 2 pi r dr dt, right? We need to show, we're trying to show that we want these two things to be what?
Related.
Directly proportional, right? Directly proportional. So let's take a look. 2 pi r squared dr dt over what?
Pi r
2 pi r
dr
dr dt. What's the proportion, right? So look, remember what we looked at here? If f of x equals k times g of x, f and g are said to be directly proportional, right? How do you find k? If you want to isolate k, what do?
You divide.
He asked for the change of the volume and with direct.
It's not this. We don't want this. We just want pi r squared. So you take this, put it there, and you take this and put it here, and look what happens. Pi r squared, right?
So the constant's just 2, right?
What cancels?
r squared.
Pi r squared. So you're left with what? 2 dr dt, right? That's not a final answer because that's not a constant, right? But what do we know? What is dh dt always?
dh dt is negative 3 over 10.
Yes, exactly. And we know that h is always equal to, we already did this once, I'm repeating, 2r, right? So we know that dh dt is equal to what? 2 dr dt, right? So we know that negative 3 over 10 is equal to 2. Remember we did this before? What is dr dt? Dr dt is always constant. So what do you end up with? Negative what?
3 over 10.
Negative 3 over 20. You take this, you plug it in, you end up with 2 times negative 3 over 20, and what do you end up with?
Wait, negative 6 over 20.
Negative 3 over 10.
Yeah, wait, you didn't even have to go that far. The h over dt is